Hello everyone, now we are going to solve the questions based on the static balancing of rotating masses. Four masses A, B, C, D are attached to a shaft and revolve in the same plane. The masses are 12 kg, 10 kg, 18 and 15 kg respectively. The radii of rotations are given 40, 50, 60 and 30 mm. The angular position of mass B, C, D, we always consider one mass's position as horizontal just to consider reference. Okay, so that's why the angular position of the masses B, C, and D are given. Okay, this is measured from the position of the mass A. Here in the question it is given that from the mass A. So let me draw the diagram. You need to understand. This is the horizontal position. Okay, this is the position of mass A. Okay, this is MA. Other masses position are measured from the position of A. There is no successive. Okay, there is no successive position. This is MB, 60 degree measured from here. Okay, this is 60 degree and 135 means it would be somewhere here. This is M3. Remember that there is no successive term is used here. That means the position is measured from the mass A. This is in horizontal direction. So 135 is measured from here. So it would be 135. Okay, and 270 would be here. Okay, this is the position of the fourth mass M4 and it is 270. Now the radius of balancing mass, what is asking magnitude and the position of the balancing mass at a radius of 100 mm. That means balancing mass radius is given, that is 100 mm, 0.1 meter. Again, we need to calculate the balancing mass position as well as the magnitude. So we all know the procedure. First you need to write down the formula, that is MBRB is equal to under root of minus of summation of MR cos of theta whole square plus minus of summation of MR sin theta whole square. First we need to calculate summation of MR cos of theta, horizontal components, horizontal forces. So that means M1 R1 cos theta 1, M1 R1 cos theta 1 plus how many masses are there? M2 R2 cos theta 2, 4 masses are there, plus M3 R3 cos of theta 3 plus M4 R4 cos of theta 4. You can consider MARA, MBRB like that. Okay. So what is M1 R1? You can calculate separately in order to minimize the error of calculations. M1 R1 is equal to what? M1 is 12 kilogram. You can see here M1 is 12 kilogram and R1 is 40. So that is 12 multiply 40 is in mm. So we need to consider in meter. We will get 0.48 kilogram into meter. Similarly, M2 R2 you can calculate. M2 is 10 kilogram and R2 is 50. So 10 multiply 0.05 will get 0.5 kilogram into meter. Similarly, M3 R3 you can calculate. M3 is 18 and R3 is 60. So 18 multiplies 60 mm, that is 0.06 meter. We will get 1.08 kilogram into meter. Okay. M4 R4. M4 is 15 kilogram and R4 is 30. 0.03. So it would becomes 0.45. Okay, and what is theta 1? Theta 1 is 0 because it is a horizontal reference, and theta 2 is 60 degree. Okay, 60 degree. Theta 3 is 135 and theta 4 is 270 degree. We just have to put these values in the equation number 1. This is in these equations. Okay, so when you solve these equations, and you will get the value of summation of mr cos of theta, that would become 0.48 cos of 0 plus 0.5 cos of 60 degree plus 1.08 cos of 135 plus 0.45 cos of 270. Okay, so you just have to calculate this. This would be cos 01, we know that, so it would be 0.48. And what is cos 60? Cos 60 is 0.5, multiply 0.5, you will get 0.25 here. Okay, and what is cos 135? It is minus 0.707, multiply 1.08, you will get minus, you will get minus 0.763. 0.763. Careful about the calculations, don't make any mistake in the sign convention also. And we know that cos 70 is 0. Okay, so when you solve this, you will get the value minus 0.033. Okay, this would be the value, kilogram into meter. Similarly, you have to calculate summation of mr sin theta. Okay, so directly I am putting the value here, 0.48 sin 0 plus 0.5 sin 60 plus 1.08 sin 135 plus 0.45 sin 270. Sin 0 is 0, it would become 0. What is sin 60? Under root of 3 by 2. So that is 0.866, multiply 0.5, it would become 0.433. Okay, and sin 135 is 0.707, and when you multiply this 1.0, you will get 0.763 plus sin 270 value is equal to minus 1. Okay, so there will be a minus sign, minus 0.45. Okay, so when you calculate this, you will get the value, and it would be 0.746 kilogram into meter. You just have to put this value in the equation number 1 here. So what would be the value from equation number 1? From equation number 1, MB RB. What is RB? RB is 0.1, which is given in the question. That is under root of minus of summation of MR cos theta minus of 0.033. So it would becomes plus 0.033 square plus minus 0.746. Okay, so when you calculate this, you will get the value that would comes out to be 0.746. Okay, so from here you can get the value of balancing mass. So it would comes out to be 7.46 kilogram. Okay, because RB is given here, this is MP 0.1. So from here you can get the value of balancing mass. This is the magnitude of the balancing mass. We also have to find out the position of the balancing mass. We don't know what is the position, so we must have to write down the formula for position. So that is tan theta b. This is the balancing mass position. You know this, it is equal to minus of summation of mr sin theta upon minus of summation of mr cos theta. Why I'm considering minus sign here? Because it will decide the quadrant. Okay, it will decide the quadrant in which quadrant the balancing mass is there. So, and summation of mr sin theta is 0.74646 upon minus, and summation of mr cos theta is minus 0.0 minus 0.033. So it will become plus. So that means minus 0. You must have to do the calculations carefully. This would become plus. That means plus 0.033, and we know that it represents y coordinate and it represents x coordinate. Okay, so it would be plus minus. So that means it represents the fourth quadrant. It represents fourth quadrant. Okay, so now here when you calculate this value, you will get the value of tan theta. That would comes out to be, theta b value comes out to be 87.46 degree. But remember that this is not the answer. Okay, if you write down this answer, you have to mention that it is measured from the position of A in the clockwise direction. Okay, but basically it is not the correct answer, because this is, it represents actually first quadrant. You can see here it representing the first quadrant, because we measured the angle in anti-clockwise direction. All the angle are measured in anti-clockwise direction. Okay, so that's why it's representing the first quadrant. So it will not be the correct answer, because we know that the position of the balancing mass is in fourth quadrant. Okay, fourth quadrant means you have to subtract it from 360 degree. So that's why you can, either you can write it as clockwise. Okay, then it is correct. Okay, you have to mention clockwise, or you can consider 360 minus. So it would become 272.53. Okay, it is the angle measured in anti-clockwise direction, as we have done for all the masses. Either you can write this, or you can write this, but you have to mention here clockwise. Okay, so this is the answer. I hope you will understand how to solve the questions on this static balancing of rotating masses. So thank